The universe has always been the grandest mystery, a cosmic puzzle that defies our wildest imaginations. Think about this for a moment. Every star you see in the night sky is just a tiny glimpse of a reality so vast, so incomprehensible, that even our most advanced scientists are constantly left speechless by its secrets. Just when we think we've figured something out, the cosmos throws another curveball, revealing truths so bizarre they sound like science fiction. And here's the thing, you're about to uncover 30 of these mind-blowing revelations that will leave you questioning everything you thought you knew about space, time, and reality itself. Picture standing at the edge of an endless ocean, but instead of water, it's a sea of galaxies stretching beyond the limits of human comprehension. Somewhere out there, black holes warp the fabric of space-time, invisible dark matter holds the universe together like cosmic glue, and entire planets could be made of diamond. These aren't just hypothetical ideas, they're real, documented phenomena that challenge our understanding of existence. And the craziest part, this is just the tip of the cosmic iceberg. Every discovery peels back another layer, revealing even more questions, more wonders, more mysteries waiting to be solved. So why does any of this matter? Because the universe isn't just some distant, indifferent void, it's our home, and its secrets are woven into the very fabric of who we are. The atoms in your body were forged in the hearts of ancient stars, and the laws that govern the cosmos are the same ones that shape your everyday life. By uncovering these truths, we're not just exploring space, we're uncovering the story of ourselves, and trust me, by the time we're done, you'll never look at the night sky the same way again. So buckle up, because what you're about to discover will stretch your mind to the absolute limits of what's possible. Are you ready? Let's dive in. Here's something that will completely shift how you see the cosmos. What we call the universe is just the tiny fraction we can actually observe. In reality, over 95% of everything that exists is completely invisible to us. This isn't some sci-fi concept, it's the startling truth about dark matter and dark energy, the mysterious forces that shape the universe on a scale we're only beginning to grasp. Think of it like this: if the entire cosmos were an iceberg, the stars, planets, and galaxies we see would just be the very tip poking above the water. The rest of the vast, unseen bulk is made up of these invisible components. Dark matter, for instance, doesn't emit, absorb, or reflect light, which means our telescopes can't detect it directly. So how do we even know it's there? Because its gravitational pull is undeniable. Galaxies spin so fast that they should fling themselves apart, yet something invisible holds them together. That something is dark matter, acting like cosmic scaffolding, keeping everything in place. Then there's dark energy, an even more baffling phenomenon. Unlike dark matter, which pulls things together, dark energy pushes the universe apart, accelerating its expansion at an ever-increasing rate. Imagine blowing up a balloon with dots on its surface. As it inflates, the dots move away from each other. Now picture that balloon inflating faster and faster for no obvious reason. That's what dark energy is doing to our universe. The wildest part, we still have no idea what these forces truly are. They don't fit into our current understanding of physics, and yet without them, the cosmos as we know it wouldn't exist. So every time you look up at the night sky, remember, you're not just seeing the universe. You're barely scratching its surface. Time isn't the constant, unchanging force we experience in our daily lives near a black hole. It becomes something far stranger. Einstein's theory of relativity revealed that gravity doesn't just bend space, it warps time itself. The stronger the gravity, the slower time moves. And nowhere is this effect more extreme than at the edge of a black hole, where gravity is so intense that not even light can escape. Think about the movie Interstellar, where the crew visits a planet orbiting Gargantua, a supermassive black hole. For every hour they spend on that world, years pass for someone back on Earth. That's not just Hollywood exaggeration, it's real physics. Near a black hole's event horizon, time drags to a crawl compared to distant space. If you could hover just outside that point and somehow survive, watching the universe beyond would seem like a fast-forwarded movie. Stars would streak across the sky, galaxies would evolve in moments, and entire civilizations could rise and fall in what feels like an instant. But here's the real kicker: you wouldn't feel anything different. Your watch would tick normally, your heartbeat wouldn't slow down, time would only seem to speed up for the rest of the universe from your perspective. This bizarre effect, called gravitational time dilation, has actually been measured here on Earth. Atomic clocks on satellites, which experience slightly weaker gravity than those on the ground, run just a fraction of a second faster over time. Near a black hole, though, the difference wouldn't be a few nanoseconds, it could be centuries. Why does this matter? Because it shows that time isn't some rigid background to the universe. It's fluid, bending under the weight of matter and energy. Black holes are nature's ultimate time machines, stretching the very fabric of reality in ways that still baffle even the brightest minds. And every time we test Einstein's predictions, from GPS satellites to ripples in space-time itself, the universe confirms just how strange and malleable time truly is. Here's a fact that will make you feel incredibly small, and yet strangely connected to the cosmos. Scientists estimate there are more stars in the observable universe than grains of sand on every beach and desert on Earth. Let that sink in for a moment. Our own Milky Way alone contains roughly 100 billion stars, each one a sun, many with their own planets, moons, and possibly even life. And here's the staggering part: our galaxy is just one of trillions scattered across the universe. To put this into perspective, imagine standing on a beach, scooping up a handful of sand. A single handful might hold thousands of grains. Now picture every beach, every desert, every speck of sand on our planet, multiply that number by 10. That's roughly how many stars exist beyond our world. If you tried counting them at a rate of 1 per second, you'd be at it for thousands of lifetimes and still barely make a dent. But here's what's even more mind-blowing: this isn't just about incomprehensibly large numbers, it's about what those numbers mean. Every one of those stars is a cosmic furnace, forging elements that eventually become the building blocks of planets, oceans, and even us. The carbon in your bones, the iron in your blood, all of it was born in the fiery hearts of ancient stars that lived and died long before our solar system existed. So the next time you see a starry sky, remember each tiny point of light isn't just a distant sun, it's a reminder that we're part of something far grander than we can fully grasp. And somewhere out there, among those countless stars, there might just be another world looking back at ours, wondering the same thing. Right now, as you read this, our moon is slowly slipping away from Earth, not in some dramatic escape, but at a pace so gradual you'd never notice. Every year, the moon moves about 3.8 centimeters farther into the cosmic void, thanks to the invisible tug of war between Earth and its celestial companion. This dance is driven by tidal forces, the same gravitational pull that gives us ocean tides. But here's the twist: those tides don't just affect our oceans, they're reshaping the entire Earth-Moon relationship. When the moon's gravity pulls on Earth, it doesn't just lift the water, it stretches the planet itself ever so slightly, creating a bulge. As Earth rotates, that bulge is dragged slightly ahead of the moon's position in its orbit. This creates a gravitational imbalance. The bulge pulls the moon forward, accelerating it just enough to push it into a higher orbit. It's like a cosmic game of crack the whip, where Earth's rotation is transferring energy to the moon, nudging it farther away each year. Now, this might not sound like much. 3.8 centimeters is barely longer than your thumb, but over time, those tiny shifts add up in profound ways. Take solar eclipses, for example. The moon's current distance from Earth is perfect for creating total eclipses, where it completely blocks the sun, but as the moon drifts farther away, it will appear smaller in our sky. In about 600 million years, it'll be too far to fully cover the sun, marking the end of total solar eclipses as we know them. And here's the real kicker: This slow-motion escape is also putting the brakes on Earth itself. The energy the Moon steals from our planet's rotation is slowing down our days by about 1.0 milliseconds per century. That might not seem like much now, but over billions of years, Earth's rotation will keep slowing until it matches the Moon's orbit, leaving one side of our planet forever locked in moonlight. Imagine a distant future where Earth no longer spins, where one hemisphere bakes in eternal daylight while the other freezes in endless night. So while the Moon's retreat feels insignificant today, it's quietly rewriting the future of our world. Every tide that rolls in, every eclipse that darkens the sky, they're all part of a celestial countdown, a reminder that even the grandest cosmic relationships are always in motion. That beam of sunlight warming your face right now, it's far older than you think, older than human civilization, older than the pyramids, older than the very concept of timekeeping. The light we see from the sun today began its journey not 8 minutes ago, as most people assume, but a staggering 30,000 years in the past. Here's the catch: those photons didn't take millennia to travel from the sun to Earth. They spent almost all the time trapped in an endless cosmic pinball game inside the sun itself. Picture the sun's core, where temperatures reach 15 million degrees Celsius. Here, hydrogen atoms fuse into helium, releasing energy in the form of photons, particles of light. But these newborn photons don't zip straight out into space. Instead, they're immediately absorbed by the dense soup of plasma surrounding them, only to be re-emitted moments later in a random direction. This happens over and over. A single photon might be absorbed and re-emitted trillions of times before it finally reaches the sun's surface. Scientists call this the random walk, and it turns what should be a 2.5-second journey into a 30,000-year odyssey. Once those photons finally escape the sun's surface, though, that's when things get fast. In the vacuum of space, light travels at its maximum speed, about 300,000 kilometers per second. From there, it's a brisk 8-minute sprint to Earth. So while the sunlight you see left the sun's surface 8 minutes ago, the energy itself has been fighting its way outward since the last ice age. This bizarre timescale reveals something profound about the nature of stars. The sun isn't just a ball of fire, it's an unimaginably dense obstacle course, where energy takes generations to break free. And every photon that reaches us is a survivor, a tiny time traveler carrying stories from an era when humans were just beginning to tell their own. So the next time you step outside and feel the sun's warmth, remember, you're not just basking in light. You're touching a message from deep time itself. We often imagine space as a vast, silent void, but the reality is far stranger. Out there, beyond our atmosphere, planets and stars are constantly singing. Not with sound as we know it. Of course, space is a near-perfect vacuum, so traditional sound waves can't travel, but electromagnetic vibrations ripple through the cosmos, and when converted into frequencies we can hear, they reveal an otherworldly symphony. Take Saturn, for example. NASA Cassini spacecraft detected intense radio emissions from the ringed planet, created by charged particles spiraling along its magnetic field lines. When scientists shifted these frequencies into the human hearing range, they uncovered something haunting: a chorus of crackles, whistles, and ethereal hums, pulsing like some alien transmission. Jupiter's auroras produce similar eerie sounds, generated by plasma waves dancing between the gas giant and its moons. Even the sun has a voice. Its superheated corona vibrates with low-frequency pressure waves that, when sped up, resemble a deep, rhythmic heartbeat. But perhaps the most unsettling space sounds come from black holes. In 2022, NASA sonified the pressure waves radiating from the Perseus galaxy cluster, where a supermassive black hole has been sending ripples through scorching intergalactic gas for millennia. The result, a spine-chilling drone, like a cosmic bass note played on an instrument we can't comprehend. These sounds aren't just curiosities, they're tools. Scientists use them to map magnetic fields, study planetary atmospheres, and even probe the structure of space-time itself, so next time you gaze up at the stars, remember, the universe isn't mute. It's a grand vibrating orchestra, playing a concert we're only beginning to decode, and with every probe we send into the darkness, we're tuning into frequencies that might one day reveal the deepest secrets of the cosmos. Venus might be Earth's twin in size, but its surface is something out of a sci-fi nightmare, a place where the very mountains are capped with metallic snow. Not the fluffy white kind we're used to, but a bizarre precipitation of heavy metals like galena and bismuth sulfide, forming glittering, corrosive crests atop its highest peaks. How does this happen? Blame Venus's hellish atmosphere, a crushing mix of carbon dioxide and sulfuric acid clouds that create surface pressures 90 times heavier than Earth's and temperatures hot enough to melt lead. Here's the wild part: while Venus's lowlands are scorching deserts, its mountains are just cool enough, relatively speaking, to allow certain metallic vapors to condense. Picture volcanic gases rich with lead and bismuth rising into the slightly cooler high-altitude air, where they solidify into crystalline flakes. These aren't delicate snowflakes, though. This snow is more like a metallic frost, clinging to rocks in razor-thin layers that shimmer under the perpetual orange haze. Scientists suspect it might even be electrically conductive, thanks to the minerals involved. What makes this even stranger? Earth has something vaguely similar, not metal snow, but frosts of rare compounds like tellurium or selenium near volcanic vents. On Venus, though, the scale is apocalyptic. Maxwell Montes, the planet's tallest mountain range, might be dusted with this eerie metallic snowfall, like something from an alien alchemist's dream. And because Venus's atmosphere is so dense, these particles don't drift gently down, they're more likely swept sideways in hurricane-force winds, sand blasting the landscape as they go. This isn't just a curiosity, it's a clue. Venus's metal snow hints at how minerals behave under extreme conditions, offering a glimpse into processes that might occur on exoplanets with even harsher environments. So while we'll never ski those slopes, the idea of a world where mountains wear crowns of gleaming metal reminds us, the universe is far stranger than anything we could invent. Imagine a cosmic ballet spinning so fast it defies all logic, a teaspoon of material weighing 1 billion tons, whirling faster than a kitchen blender. That's the reality of neutron stars, the collapsed cores of massive stars that didn't quite become black holes. These stellar remnants pack more mass than our Sun into a sphere no wider than a city, and they spin at speeds that would vaporize any known material on Earth. Some complete up to 600 rotations every second, their surfaces moving at nearly a quarter the speed of light. How does something so dense spin so wildly? The answer lies in one of physics' most fundamental laws, the conservation of angular momentum. When a massive star explodes in a supernova, its core collapses inward, shrinking from millions of kilometers across to just a dozen miles. Just like an ice skater pulling in their arms to spin faster, this sudden contraction sends the star's rotation into overdrive. The original star might have rotated once every few weeks, but now, compressed into a neutron star, that same spin becomes a dizzying blur. But the extremes don't stop there. Neutron stars aren't just fast, they're perfectly smooth. Despite their unimaginable gravity, their surfaces are thought to have microscopic irregularities no taller than a millimeter. Any larger mountains would collapse under their own weight, crushed by gravity so intense it warps atoms into spaghetti-like strands, yet these spinning powerhouses aren't silent. Many emit beams of radiation from their magnetic poles, sweeping across space like cosmic lighthouses. When these beams point toward Earth, we detect them as pulsars, precise celestial metronomes blinking with a regularity that rivals atomic clocks. Here's the wildest part: some neutron stars don't just spin, they glitch. Without warning, their rotation can suddenly speed up, as if the universe itself hit a cosmic fast-forward button. Scientists suspect these glitches occur when the star's crust, frozen solid by gravity, momentarily cracks and adjusts to the swirling superfluid beneath it. It's a reminder that even in death, stars remain dynamic, unpredictable, and utterly mesmerizing, so the next time you hear about one of these cosmic speed demons, remember you're not just learning about a distant object. You're glimpsing the universe's ability to turn catastrophe into something staggeringly beautiful. Somewhere in the vast emptiness of space, a giant cosmic cloud smells uncannily like a bowl of fresh raspberries. No, this isn't a scene from a whimsical space opera, it's actual science. Astronomers analyzing the Sagittarius B2 molecular cloud, a massive star-forming region near the center of our galaxy, made a deliciously bizarre discovery. It contains ethyl formate, the very same compound that gives raspberries their sweet, fruity aroma. Now, before you picture floating through space like a kid in an intergalactic candy store, there's a catch. That raspberry-scented molecule is mixed with a cocktail of other chemicals, including propyl cyanide, which unfortunately smells like rum. Not the refined, aged kind, but the harsh, burning alcohol variety, so if you could somehow take a whiff of this cosmic cloud, you'd get a confusing blend of freshly picked berries and a questionable dive bar. But why does any of this matter? Because these molecules are the building blocks of life. Ethyl formate doesn't just make raspberries smell appealing, it's also a key ingredient in the formation of amino acids, the foundation of proteins. The same processes brewing in these interstellar clouds could be how life's essential ingredients first spread through the universe. Think of it like stumbling upon a cosmic kitchen where the universe is secretly baking the precursors to existence itself. Here's the kicker: this isn't the only flavor we've detected in space. Other clouds contain acetic acid, the sharp bite of vinegar, glycolaldehyde sugar, and even hydrogen sulfide, which, let's be honest, smells like rotten eggs. It's as if the cosmos is an experimental chef, tossing together wildly contrasting tastes and scents to see what sticks. So next time you bite into a raspberry, remember, you're tasting something the universe has been cooking up for billions of years. And somewhere out there, drifting through the void, there might just be a gas cloud waiting to surprise another civilization with its unexpected, fruity perfume. Deep in the constellation Boötes lies one of the universe's greatest mysteries, a cosmic desert so vast it defies explanation. The Boötes void stretches an astonishing 330 million light-years across, yet contains almost nothing. No galaxies, no stars, just an eerie, empty expanse that earned the nickname, the Great Nothing. To put that into perspective, if our Milky Way were placed at its center, we'd see fewer than 60 galaxies in any direction compared to the thousands we'd expect in a region that size. It's as if someone carved out a spherical chunk of the universe and left behind only darkness. So how does something like this even form? Astronomers have several theories, each more mind-bending than the last. One possibility is that the void is the aftermath of an ancient cosmic collision where smaller voids merged over billions of years, gobbling up galaxies in their expansion like bubbles merging in a fizzy drink. Another idea suggests it's evidence of a mind-boggling phenomenon called quantum tunneling on a cosmic scale, where an entire region of space somehow transitioned to a lower energy state early in the universe's history, leaving behind this barren pocket. But here's the real puzzle: voids like this shouldn't exist under our current understanding of cosmology. The Big Bang's afterglow, the cosmic microwave background, shows a universe that's remarkably uniform, with matter distributed fairly evenly. The Boötes void throws a wrench into that idea, forcing scientists to question whether there are even larger structures or forces at work we haven't discovered yet. Some speculate it might be a footprint of an unimaginably vast cosmic defect, like a wrinkle in space-time itself from the universe's earliest moments. What makes this emptiness so unsettling isn't just its size, it's what it implies about the cosmos. If regions this barren can exist, Does that mean there are others? Could there be voids so large they've remained invisible simply because there's no light within them to reveal their presence? It's a humbling reminder that for all we've mapped, the universe still holds shadows big enough to swallow our assumptions whole, and as telescopes grow more powerful, who knows what other gaps in reality we might uncover. Here's a cosmic thought that will rearrange your sense of scale. Every planet in our solar system, lined up side by side, could fit snugly in the gap between Earth and the Moon. At first glance, that sounds impossible. After all, Jupiter alone is wider than 11 Earths stacked together, and Saturn's rings could swallow 6 of us with room to spare. But when you crunch the numbers, the math doesn't lie. The combined diameters of all 8 planets add up to roughly 380,000 kilometers, and the Moon's average distance from Earth, about 384,000 kilometers. That leaves just enough space for a celestial conga line with 4,000 kilometers to spare, like a planetary parking job, precision engineered by the universe itself. Let's break it down. Start with Jupiter, the solar system's titan, stretching 140,000 kilometers across, slot in Saturn next at 116,000, then Uranus and Neptune at roughly 51 and 49,000 respectively. The rocky planets Earth, Venus, Mars, and Mercury are practically crumbs in comparison, adding up to just over 38,000 kilometers combined. Even if you tossed in Pluto, which we're not, out of respect for astronomers, you'd still have wiggle room. The real kicker, this cosmic snugness isn't static. The Moon's orbit isn't a perfect circle at its farthest point. The planets would scrape by with less than 2,000 kilometers to spare, but during the Moon's closest approach, they'd rattle around with an extra 15,000 kilometers of void between them. Now imagine this lineup in the sky. From Earth's surface, Jupiter would loom larger than 10 full moons side by side, its stormy bands visible to the naked eye. Saturn's rings would stretch across half the heavens, casting shimmering shadows on the Martian rust below. The ice giants Uranus and Neptune would glow like faint turquoise marbles near the Moon's orbit, while Venus and Mercury would cling to the inner lane, barely distinguishable from bright stars. It's a mind-bending reminder of how empty space truly is. Despite their immense sizes, the planets are just specks adrift in an ocean of nothingness. But here's what makes this fact more than just a party trick: it reveals a hidden symmetry in our celestial neighborhood. The distance between Earth and the Moon isn't arbitrary. It's a fingerprint of gravity's delicate dance, where our planet's pull balances the Moon's momentum. That the planets almost fill that gap hints at deeper patterns woven into the solar system's design. It's as if the universe left itself a margin of error, a whisper of extra space to keep the cosmic machinery running smoothly. So next time you see the Moon hanging in the twilight, picture this: out there, in the void between you and that glowing orb, there's just enough room for every world we've ever known to take their bow. Jupiter's great red spot, that colossal, swirling storm big enough to swallow Earth whole, has been a fixture in our solar system for centuries. A tempest so vast and enduring, it became the very symbol of Jupiter itself. But something unsettling is happening. This ancient vortex, once a titan stretching 25,000 miles across, is shrinking at an alarming rate. Recent measurements reveal it's now barely half its historic size, and scientists are racing to understand whether we're witnessing the slow death of the solar system's most famous storm. The Great Red Spot story begins in the early 1700s, when astronomers first trained their crude telescopes on Jupiter and noticed a persistent, brick-colored blemish in its southern hemisphere. By the time detailed observations began in the late 19th century, the storm was a behemoth 3 times wider than Earth, with winds screaming at 400 miles per hour. For generations it seemed unchanging, a permanent fixture in the Jovian sky. Then in the 1980s, something shifted. High-resolution images from Voyager and subsequent spacecraft revealed the unthinkable. The spot wasn't just shrinking, it was doing so exponentially. In the past 40 years alone, It's lost nearly 900 miles in width annually, morphing from a wide oval into something more like a cosmic pancake. What's causing this slow-motion collapse? One theory points to Jupiter's turbulent jet streams, which may be stealing energy from the storm, weakening its rotation like a spinning top running out of steam. Another suggests smaller Eda's miniature storms are chipping away at its edges, eroding it from the outside in, the most haunting possibility that the spot is simply running out of the atmospheric fuel that sustained it for centuries. Unlike Earth's hurricanes, which draw power from warm ocean waters, Jupiter's megastorm feeds on vertical wind shear and heat rising from the planet's core. If that energy source is waning, the spot could be starving to death. The implications are profound. If the Great Red Spot vanishes entirely, something that could happen within our lifetimes, it would mark the end of a celestial era. This isn't just about losing a pretty feature in a telescope, it's about watching a fundamental piece of our understanding of planetary atmospheres flicker out. Jupiter's storm has taught us how long-lived weather systems behave, how energy circulates in gas giants, even how similar vortices might operate on exoplanets light years away. Its decline raises urgent questions. Is this a natural life cycle for such storms, or is Jupiter's climate shifting in ways we don't yet grasp? Here's the most tantalizing mystery of all: the spot might not be dying, but transforming. Recent observations show it's growing taller even as it narrows, stretching upward like taffy. Some scientists speculate it could evolve into a totally new structure, perhaps an elongated cyclone, or even a chain of smaller storms. Whatever happens next, one thing is certain: we're witnessing cosmic history in real time, a reminder that even the mightiest phenomena in our universe are fleeting. So the next time you see Jupiter gleaming in the night sky, take a moment to appreciate the Great Red Spot, because it might not be there forever. You might think of stars as unimaginably hot celestial infernos, but the universe has a way of defying expectations, like the existence of stars that are literally cooler than your body temperature. Meet the Y-class brown dwarfs, cosmic oddballs so chilly that their surfaces hover below 100 degrees Fahrenheit, making them colder than a summer day on Earth. These strange objects blur the line between star and planet, earning them the nickname failed stars, because they never quite mustered the heat and pressure needed to ignite sustained nuclear fusion in their cores. So how does something qualify as a star if it can't even properly burn? Brown dwarfs start off like regular stars, collapsing from vast clouds of gas and dust. But if they're too small, typically less than 7%, the mass of our Sun, their cores never reach the 10 million degree mark, required to fuse hydrogen into helium. Instead, they smolder in cosmic limbo, radiating only the faint warmth left over from their gravitational collapse. The smallest and coolest of these, the Y dwarfs, are so cold that if you could somehow stand on one ignoring the crushing gravity and lack of breathable air, you'd need a jacket to stay comfortable. What's truly bizarre is how we detect these lukewarm giants. Unlike the blazing stars we see in the night sky, Y dwarfs emit almost no visible light. Instead, they glow dimly in infrared, like dying embers in a cosmic campfire. The coldest known example, Y0855-0714, sits just 7.2 light-years away with a surface temperature of negative 54 degrees Fahrenheit colder than a winter night in Antarctica. To put that in perspective, this star is closer to the temperature of Jupiter than to our Sun, but here's where it gets even weirder: some Y dwarfs may have clouds. Not fluffy water vapor like Earth's, but swirling storms of molten iron or sand, condensing in atmospheres thick with methane and ammonia. Picture a world where the rain is liquid metal, falling through skies choked with exotic chemistry. These failed stars challenge everything we thought we knew about stellar classification, proving that the universe has a flair for creating hybrids that defy easy categorization. So the next time you step outside and feel the sun's warmth, remember, somewhere out there, a star might be shivering in the dark. Looking into the depths of the universe is like staring into a cosmic mirror, because 2.5 million light-years away, there's a galaxy that could pass for the Milky Way's identical twin. Meet NGC 6744, a stunning spiral so similar to our own galaxy that astronomers often refer to it as the Milky Way's doppelganger. From its sweeping arms dusted with pink star-forming regions to its bright, elongated core, this celestial sibling offers us something extraordinary, a chance to study our own galaxy from the outside, something we'll never be able to do firsthand. What makes this galactic twin so uncanny? Start with the basics. Both galaxies are barred spirals, meaning their stars aren't just scattered randomly, they're organized around a central bar-shaped structure. NGC 6744's spiral arms unfurl across nearly 175,000 light-years, making it slightly larger than the Milky Way, but the resemblance doesn't stop there. Like ours, it boasts a mix of young blue star clusters and older, yellower stars, with dark lanes of cosmic dust weaving through its disk. Even its star formation rate is eerily similar, with new suns igniting along its arms at a pace that matches our galaxy's. But here's why this cosmic mirror matters. Unlike the Milky Way, which we're stuck inside, NGC 6744 lets us see the big picture. Imagine trying to map the floor plan of your house while standing in a single room with no windows. That's the challenge we face studying our own galaxy, obscured as it is by gas, dust, and our own position within it. With NGC 6744, we get the aerial view, revealing how spiral arms connect, where star formation peaks, and how the central bar influences the motion of stars. It's like finally seeing the blueprint of your home after years of guessing. There's one tantalizing difference, though: NGC 6744's halo. Surrounding most galaxies, including ours, is a vast cloud of ancient stars, dark matter, and stray gas, but this twin's halo is littered with unusually bright star clusters, far more luminous than anything in the Milky Way's outskirts. Some scientists speculate these could be the remnants of smaller galaxies it's devoured, galactic crumbs left over from cosmic feasts. If true, it suggests our twin might be more voracious than we are, offering clues about how galaxies grow over billions of years. So the next time you gaze up at the Milky Way's shimmering band, remember there's another version of it out there, spinning in the darkness. And by studying this mirror image, we're not just learning about a distant galaxy. We're piecing together the story of our own celestial home. Imagine floating aboard the International Space Station, only to realize your pants no longer fit, not because you've been hitting the cosmic buffet, but because space itself has stretched you taller. This isn't science fiction. Astronauts routinely grow up to 3% in height during their time in orbit, thanks to the spine's bizarre response to microgravity. On Earth, gravity compresses the vertebrae like a stack of pancakes, but without that constant downward pull, the spine relaxes and expands, sometimes adding as much as 2 inches to an astronaut's frame. The phenomenon isn't just a quirky side effect, it's a literal pain in the back. As the vertebrae separate, the surrounding muscles and ligaments stretch uncomfortably, leading to what NASA jokingly calls space hitchhiker's posture. Early missions reported crew members suddenly towering over their pre-flight measurements, only to shrink back down within hours of returning to Earth's gravity. Japanese astronaut Norishige Kan, I once famously tweeted his alarm after measuring a shocking 2-inch growth spurt, though he later corrected it to a more modest, but still startling 3/4 of an inch. But here's where it gets even wilder. This cosmic growth spurt can turn mundane tasks into comedy gold. Astronauts have woken up to find their sleeves riding up their arms, their socks failing to reach their ankles, and even their custom-fitted spacesuits feeling suspiciously snug. On one mission, a crew member's sudden height gain meant their carefully stowed exercise harness no longer clipped properly, leading to an impromptu session of zero-gravity Mach jivering. The real kicker: unlike puberty, this growth isn't permanent. Within months of returning home, gravity reasserts its dominance, squishing the spine back to its original length, often with a chorus of pops and aches that make it clear the universe doesn't give out free height without a payback. What's fascinating is how this mirrors a much older human experience, medieval torture racks. Both rely on the spine's ability to stretch under tension, though astronauts get the gentler and far more voluntary version. Scientists now study these changes to understand back pain on Earth, exploring how microgravity could one day help treat spinal injuries. So while you might not book a spaceflight just to gain an inch, it's a hilarious reminder that even our bodies can't resist the universe's knack for bending the rules. Earth's celestial entourage isn't limited to the moon, turns out. We've had a secret second companion hiding in plain sight. Meet Kamolwa, a tiny asteroid no bigger than a Ferris wheel, locked in a delicate orbital waltz with our planet. This isn't some distant space rock drifting by, it's what astronomers call a quasi-moon, an object trapped in Earth's gravitational embrace for centuries at a time, mimicking a true satellite without ever officially becoming one. What makes Kamolwa so fascinating is its peculiar path. Unlike the moon's neat, elliptical orbit, this asteroid follows a bizarre, corkscrew-like trajectory around the sun that keeps it perpetually near Earth. Picture a car on a cosmic roundabout, occasionally pacing alongside us but never fully exiting the celestial highway. Most quasi-moons are temporary hitchhikers. Kamolwa, for instance, has been shadowing us since at least the year 100, and simulations suggest it'll break free around the year 3800. But here's the twist: this asteroid might not be just another space pebble. Observations reveal its surface reflects light much like lunar rocks, sparking theories that it could be a chunk of the moon itself, blasted into space by an ancient impact. If true, Earth's second moon would literally be a long-lost fragment of the first, a cosmic sibling reunited after eons apart. Quasi-moons like Kamolwa aren't just curiosities, they're time capsules. Their unstable orbits make them perfect candidates for future missions, offering clues about the solar system's chaotic past, and they're more common than we thought. At least 5 other asteroids are currently dancing similar Earthbound routines. So while our skies will never show a second gleaming orb like the moon, the universe has a way of keeping us company in ways we're only beginning to uncover. Space is often described as unimaginably cold, a void where temperatures plunge hundreds of degrees below freezing. But here's the cosmic twist: even the emptiest corners of the universe aren't truly frozen at absolute zero. Instead, they hum with a faint warmth left over from the universe's explosive birth. This universal heat signature, known as the cosmic microwave background, lingers at a steady 2.7 degrees above absolute zero, about -454 degrees Fahrenheit. That might still sound icy, but it's proof that the cosmos is anything but a lifeless deep freeze. This subtle warmth isn't just random noise, it's the faded glow of the Big Bang itself, stretched and cooled over 13.8 billion years, but still detectable as a whisper of microwave radiation. Picture the universe in its infancy, a seething, opaque plasma so dense that light couldn't travel more than a fraction of an inch before being absorbed. Then, roughly 380,000 years after the Big Bang, everything cooled enough for atoms to form, allowing light to finally break free. That first flash of liberated light has been traveling ever since, red shifted by the universe's expansion into the faint microwave glow we detect today. What's astonishing is how uniform this afterglow appears no matter where you point a radio telescope. The temperature varies by less than 100,000th of a degree. That near-perfect smoothness was a major puzzle until scientists discovered microscopic ripples in the radiation, tiny fluctuations that became the seeds for galaxies, stars, and eventually, us. These imperfections are like cosmic fingerprints, revealing the density variations that gravity sculpted into the universe we recognize. But here's the real kicker: this background warmth isn't just a relic, it's still shaping the cosmos. As light from the cosmic microwave background passes through galaxy clusters, its energy gets subtly distorted by a phenomenon called the Sunyaev-Zeldovich effect, helping astronomers map the universe's hidden scaffolding of dark matter. Even now, this primordial heat serves as both a time capsule and a tool, offering clues about everything from the nature of dark energy to the universe's ultimate fate. So the next time someone calls space freezing cold, remember, it's still wrapped in the fading warmth of creation, a thermal memory of when everything began. And buried in that gentle heat are answers to questions we're only beginning to ask. Saturn's iconic rings have long been portrayed as eternal, a timeless crown woven into the fabric of the solar system itself. But here's the jaw-dropping truth: those shimmering bands of ice and dust might be younger than the dinosaurs. Recent evidence suggests they formed a mere 100 million years ago, a blink in cosmic terms when T-Rex still ruled Earth's jungles. This revelation turns centuries of assumptions upside down, proving even the most breathtaking celestial features can be fleeting. How do we know these rings aren't ancient? The clues lie in their remarkable purity. Saturn's rings are overwhelmingly made of water ice, 99% pure, gleaming so brightly they reflect more light than the planet itself. If they'd existed for billions of years, cosmic dust and meteoroid impacts should have darkened them, leaving a grimy residue like snowbanks near a busy highway. Yet data from the Cassini spacecraft revealed them to be suspiciously pristine, as if freshly sculpted. Even more telling, the ring's total mass aligns with what you'd expect from a structure that hasn't had time to accumulate debris over eons. Theories about their origins read like a cosmic crime scene. One leading idea involves a catastrophic breakup. Perhaps a moon strayed too close to Saturn and was shredded by tidal forces, its icy remains spreading into the stunning disks we see today. Another suggests a rogue comet or Kuiper belt object met a gruesome end in Saturn's gravitational grip. Whatever happened, the violence would have been spectacular, a gravitational demolition that echoed across the solar system. What's truly mind-bending is how recent this all was. When Saturn's rings first sparkled into existence, Earth's continents were still arranged differently, with the Atlantic Ocean just beginning to form. Mammals existed, but they scurried in the shadows of giants like Triceratops. Even Saturn's own moons tell a story of youth. Some, like Enceladus, show geological activity hinting they formed or were reshaped around the same time. It's as if the entire Saturnian system underwent a dramatic makeover while dinosaurs still walked below. This discovery does more than rewrite planetary history. It forces us to confront how lucky we are to witness such a temporary wonder. In another 100 million years, the rings may vanish altogether, eroded by micrometeoroids or pulled apart by gravity. Future civilizations might gaze at Saturn through telescopes and see nothing but a bare, lonely giant, its glory days lost to time. So while we marvel at those rings today, remember we're catching a cosmic performance that's both breathtakingly young and already counting down to its final bow. Imagine a world where the ground beneath your feet isn't rock or sand, but a glittering expanse of solid diamond. That's not science fiction, it's the reality of 55 Cancri, a planet just 40 light-years away that's essentially one colossal jewel. This super-Earth, twice as wide as our own planet and 8 times as massive, orbits so close to its sun that its surface is a searing 200 degrees Celsius hot enough to vaporize steel. Yet beneath that inferno lies something even more extraordinary, a vast planet-sized diamond. How does an entire world turn into a gemstone? It starts with cosmic chemistry. Most rocky planets like Earth form from silicon and oxygen-rich materials, giving us ordinary crust and mantle, but 55 Cancri was born in a carbon-heavy system, where carbon atoms outnumbered oxygen. Under the crushing pressure of the planet's immense gravity, thousands of times stronger than Earth's, those carbon atoms were squeezed into crystalline perfection, forging diamond on a scale beyond human comprehension. Some estimates suggest the diamond layer could be hundreds of miles thick, with a core of liquid carbon lurking beneath. Now, let's talk numbers. because this planet's value is as mind-bending as its geology. If we could somehow mine just 1% of 55 Cancri's diamond content, ignoring the impossibility of surviving its molten surface, it would be worth around $26 nonillion. That's a 26 followed by 30s is enough to buy every piece of property, every company, and every asset on Earth millions of times over. Of course, the universe loves irony. This ultimate treasure trove is utterly unreachable, a diamond the size of a planet floating forever out of reach. But here's the cosmic punchline: 55 Cancri might not be alone. Astronomers suspect carbon-rich worlds could be common in certain corners of the galaxy, each one a potential diamond in the rough. Some might even harbor exotic forms of carbon we've never seen, like BC8, a theoretical super-dense phase that could be 30% harder than regular diamond. It's a reminder that the universe doesn't just create beauty, it does so on scales that humble our wildest dreams. So while we'll never set foot on this glittering inferno, its existence proves a dazzling truth. Out there, the line between planet and jewel is thinner than we ever imagined. The dusty red horizon of Mars might seem like the last place you'd expect a familiar sight, but when the sun dips low in the Martian sky, something magical happens. The rusty atmosphere transforms, washing the landscape in an eerie, ethereal blue glow. Thanks to NASA Curiosity rover, we've witnessed this phenomenon firsthand: sunsets on Mars that could almost pass for Earth's, if not for the alien terrain framing them. So why does a planet known for its red deserts paint its sunsets blue? It all comes down to an atmospheric quirk. On Earth, our thick atmosphere scatters blue light during the day, giving us those iconic blue skies. At sunset, the light has to pass through more atmosphere, filtering out the blues and greens, leaving behind the warm reds and oranges we associate with twilight. Mars flips this script. Its thin, carbon dioxide-rich air is choked with fine iron-rich dust particles. These tiny motes are just the right size to scatter red light outward during the day, hence the planet's perpetual rusty haze. But when the sun hangs near the horizon, something extraordinary occurs. The sunlight must travel through so much dust that the red wavelengths get filtered out, allowing the cooler blue hues to dominate. The result, a sunset that looks like someone inverted Earth's color palette, with the sun's disk appearing pale blue against a fading rust-colored sky. Curiosity's time lapses of these events reveal just how alien yet strangely nostalgic these moments are. The sun itself looks smaller, just 2/3 the size we see from Earth, and the twilight lingers longer, thanks to the thin air scattering light less efficiently. But the real showstopper is the way the blue light clings to the Martian terrain, casting long indigo shadows across rocks that have known nothing but red skies for billions of years. It's as if Mars, for a few fleeting minutes each evening, lets its guard down and shows us a side of itself we never expected. This isn't just a pretty cosmic coincidence, it's a vital clue about Mars's past. The way light interacts with that dusty atmosphere tells scientists about particle sizes and atmospheric density, which in turn reveals how winds and storms move material around the planet. Some researchers even speculate that when Mars was younger and wetter, with thicker air and less dust, its sunsets might have looked more like ours. Now, though, they're a haunting reminder of how a single variable like the size of airborne dust grains can transform a world's entire identity. So while we often picture Mars as a monotonous red desert, the truth is far more poetic. Even in the harshest environments, the universe finds ways to surprise us with beauty, one blue sunset at a time. Mars may be the smaller sibling of our solar system, but it holds a geological champion that puts every mountain on Earth to shame. Olympus Mons, a volcano so massive it could swallow the entire state of Arizona and still have room to spare. This isn't just another tall peak, it's a staggering 16 miles high, nearly 3 times the elevation of Mount Everest. If you stood at its base, the summit would vanish into the thin Martian haze, its peak literally poking through the lower layers of the planet's atmosphere. What's truly mind-bending about Olympus Mons isn't just its height, it's how easy the climb would feel. Unlike Earth's steep, jagged mountains, this Martian titan has slopes so gentle you could hike them without realizing you're ascending. The incline averages just 5 degrees, meaning you'd walk for miles before noticing any real change in elevation. Picture strolling up a wheelchair ramp that stretches from New York to Los Angeles. That's the scale we're talking about. This bizarre flatness comes from Mars's lack of tectonic activity. On Earth, shifting plates limit how big volcanoes can grow, constantly recycling the crust. But Mars's stationary crust allowed lava to pile up in the same spot for billions of years, creating a shield volcano so wide it covers an area the size of France. Here's the kicker: Olympus Mons might still be active. Recent satellite images show evidence of lava flows as recent as 2 million years ago, a blink in geological time. Some scientists even speculate it could erupt again, given the right conditions. Imagine a volcanic eruption where the lava doesn't explode violently, but oozes out slowly, creeping down those gentle slopes like syrup on a pancake. The spectacle would unfold in eerie silence, with no sound carrying through Mars's thin air, just rivers of molten rock inching across a landscape already shaped by ancient fire. But the real wonder lies in what Olympus Mons teaches us about planetary evolution. Its existence hints at a time when Mars was geologically alive, with a molten core and erupting volcanoes that may have even contributed to a thicker atmosphere. Today it stands as a frozen monument to a more turbulent past, a reminder that even the quietest worlds once roared with unimaginable force. So the next time you see Mars glowing red in the night sky, remember there's a mountain there so vast it defies earthly logic, waiting quietly for the day we might stand on its slopes and gaze across an alien horizon. Venus might be Earth's closest planetary neighbor, but its sense of time is utterly alien, because a single day there lasts longer than its entire year. That's right, while Venus whips around the Sun in just 225 Earth days, it takes a sluggish 243 Earth days to complete one rotation on its axis. Picture celebrating your birthday before you've even finished one full day of work. You'd talk about the world's most chaotic work-life balance. This bizarre time warp happens because Venus spins backward, a phenomenon called retrograde rotation. Unlike Earth and most other planets, which rotate counterclockwise when viewed from above, Venus flips the script, spinning clockwise at a glacial pace. Combine that with its breakneck orbital speed, it's the second fastest planet in our solar system after Mercury, and you get a cosmic clock where the days outpace the years. If you lived on Venus and somehow survived its crushing atmospheric pressure and lead melting temperatures, you'd witness the sun rising in the west and setting in the east, but only once every 4 Earth months. Here's where it gets even weirder. Because of this sluggish spin, the sun doesn't just rise and set on Venus, it loiters. From the planet's surface, our star would appear to crawl across the sky, moving so slowly you could outpace its progress with a leisurely stroll. A Venusian noon would feel like an eternity, with the sun hanging motionless for weeks as the planet stubbornly refuses to turn. And if you thought time zones were confusing on Earth, imagine trying to schedule a meeting on a world where the sun sets once every 117 Earth days. Now let's talk about those birthday parties. If you aged in Venus years, you'd hit your first birthday before your first day was even over. By the time you'd experienced just 2 full sunrises, you'd already be celebrating your second trip around the sun. It's enough to make your head spin, which, ironically, is exactly what Venus isn't doing very quickly. This topsy-turvy timeline isn't just a fun fact, it's a testament to how wildly planetary dynamics can diverge. While Earth ticks along with predictable days and years, Venus dances to a rhythm all its own, reminding us that even the most familiar-looking worlds can hide clocks that run backward. The sun seems like it should follow a simple rule: the closer you get to its core, the hotter it becomes, but the universe loves breaking rules, and here's the ultimate cosmic defiance. the Sun's wispy outer atmosphere, the corona, is millions of degrees hotter than its visible surface. While the Sun's photosphere, the part we see, sizzles at around 5,500 degrees Celsius, the corona blazes at a mind-melting 1 to 3 million degrees. It's like walking away from a campfire and suddenly feeling the heat increase the farther you step back, a paradox that's baffled scientists for decades. So how does this backward heating happen? The leading theory involves the Sun's tangled magnetic fields. Imagine the Sun's surface as a bubbling pot of plasma, with magnetic field lines twisting and snapping like overstretched rubber bands. When these lines break and reconnect, they release colossal bursts of energy. Think of it as cosmic short-circuiting, in a process called magnetic reconnection. These explosions send shockwaves rippling outward, dumping enough heat into the corona to turn it into a supercharged inferno. Another possibility involves plasma waves generated by the Sun's churning interior, which travel upward and dissipate their energy in the corona, like ocean waves crashing onto a shore and dumping their power all at once. Here's where it gets even wilder. Despite its unimaginable heat, the corona doesn't feel hot in the way you'd expect. Temperature in space terms measures particle speed, not necessarily how much energy would transfer to an object. The corona's particles are zipping around at millions of degrees, but they're so spread out that if you could float through it in a magic indestructible suit, you wouldn't instantly vaporize. It'd be like standing in a sauna where the air molecules are white hot, but there are too few of them to cook you. This coronal mystery isn't just academic, it's the key to understanding solar wind, those streams of charged particles that can knock out satellites and mess with Earth's power grids. And when the corona unleashes its fury in a solar flare or coronal mass ejection, that million-degree plasma races toward us at terrifying speeds. The more we unravel this paradox, the better we can predict space weather that affects our tech-dependent world. So next time you see an eclipse and the corona gleams like a fiery halo around the moon's shadow, remember, you're looking at one of the Sun's greatest secrets, a layer of plasma that burns hotter than logic should allow, defying everything we thought we knew about heat and energy. And somewhere in that shimmering veil of light, the answers to a cosmic riddle are still waiting to be found. Somewhere in the constellation Vulpecula, a planet exists where the skies rain glass, not gentle droplets, but sideways blowing shards propelled by winds faster than a speeding bullet. Meet HD 189733b, a cobalt blue gas giant where the phrase "weather warning" takes on a whole new meaning. This exoplanet, located 63 light-years away, is a masterpiece of cosmic extremes, a world where temperatures soar to 900 degrees Celsius, and the atmosphere whips silicate particles into violent storms of molten glass. Imagine standing on this planet's hypothetical surface. If you could survive the crushing gravity and scorching heat long enough to look up, the sky wouldn't just drizzle or pour, it would shred. At 5,400 miles per hour, the winds here make Earth's strongest hurricanes seem like gentle breezes, sending clouds of condensed silicate minerals slicing horizontally through the air. These aren't delicate glass marbles, they're razor-sharp fragments, forged in the upper atmosphere where temperatures drop just enough for silicon and oxygen to solidify into microscopic daggers before the winds blast them sideways at speeds 7 times the speed of sound. What makes this glass rain even wilder is how it shapes the planet's bizarre color. 8189733b isn't blue like Earth due to water, but because those silicate particles scatter blue light in its hazy atmosphere, creating an otherworldly azure glow. Scientists discovered this using the Hubble Space Telescope, which detected how light filtered through the planet's atmosphere during transits. The same glass storms that would flay any unprotected traveler also paint the planet in a deceptively serene hue, a cosmic optical illusion where beauty and brutality collide. But here's the twist, this glass isn't permanent. The planet's scorching day side vaporizes the particles back into gas, which then circulates to the cooler night side, and condenses anew, creating an endless cycle of formation and destruction. It's a weather system where the rain evaporates before it even hits the ground, only to rise, condense, and fall again in a perpetual, planet-wide tempest. This nightmare vacation spot offers more than just shock value. It's a laboratory for understanding alien atmospheres. By studying how materials like silicates behave under such extreme conditions, scientists gain insights into the diversity of exoplanet climates. 8189733b reminds us that the universe doesn't just defy expectations, it reinvents them entirely, crafting worlds where the very concept of weather becomes a spectacle of unimaginable ferocity. So the next time you complain about a little rain, remember, out there, somewhere, a planet is turning storms into an art form no human would ever want to experience firsthand. The moon isn't the silent, lifeless orb it appears to be. It has its own seismic secrets, trembling with moonquakes powerful enough to rattle future lunar bases. When Apollo astronauts planted seismometers on its surface in the late 1960s and early 70s, they expected to record the occasional meteor impact. Instead, they discovered a world alive with vibrations, some lasting hours longer than anything on Earth. These tremors come in four flavors: deep quakes triggered by tidal forces, shallow tremors from thermal expansion, vibrations from meteorite strikes, and the eeriest of all, phantom quakes with no clear cause. Let's start with the deep moonquakes, the most predictable of the bunch. Unlike Earth's quakes, which stem from tectonic plates grinding together, these originate 600 miles below the lunar surface, where the moon's rigid structure flexes under Earth's gravitational pull. Picture squeezing a rubber ball slightly. That's what our planet's gravity does to the moon, creating rhythmic shudders every 27 days as the lunar orbit tightens and relaxes. The Apollo instruments recorded thousands of these events, some reaching magnitude 5. What's bizarre is how long they linger, up to 10 minutes of sustained shaking, compared to Earth jolts that typically fade in seconds. If you were standing on the moon during one, the ground would roll beneath you like a slow, endless wave. Then there are the shallow thermal moonquakes, caused by the moon's brutal temperature swings. When the 2-week-long lunar day begins, the surface heats from -173 degrees Celsius to 127 degrees, making the crust expand and crack like pavement in a heat wave. These quakes are small but frequent, a reminder that even without weather, the moon's environment is far from static, but the showstoppers are the meteor impacts. Without an atmosphere to burn up incoming space rocks, the moon takes a constant pummeling. The Apollo seismometers caught everything from pebble-sized strikes to mountain-smashing impacts, each sending shockwaves ricocheting through the lunar interior. Some of these seismic echoes revealed something astonishing: the moon's core is partially molten, a fact we wouldn't confirm for decades. And then there are the mystery quakes, random, high-frequency vibrations with no obvious trigger. Some scientists speculate they could be landslides in permanently shadowed craters, where frozen volatiles suddenly shift. Others wonder if the moon's crust, under eons of stress, simply snaps like a brittle wafer. Whatever the cause, they're a reminder that after 50 years, the Apollo experiments are still rewriting lunar science. Here's the kicker: moonquakes matter more than ever. With plans for permanent lunar bases, engineers need to design structures that can withstand these unique tremors. A quake that would barely rattle dishes on Earth could destabilize loose lunar regolith or crack fragile habitats. The moon's quiet reputation: it's a cosmic illusion. Beneath that serene facade lies a world that never stops shaking. What if everything you see, the stars, galaxies, even the screen in front of you right now, isn't as three-dimensional as it seems? One of the most radical ideas in modern physics suggests the entire universe might be a hologram, not the flickering sci-fi kind, but a vast cosmic projection where the true reality is encoded on a distant two-dimensional surface, like a movie playing on the universe's ultimate projector screen. This isn't just wild speculation, it's called the holographic principle. a theory born from the fiery depths of black hole physics. The story starts with a paradox. When matter falls into a black hole, according to Einstein's general relativity, it's gone forever, erased from the universe, but quantum mechanics insists information can't truly be destroyed. So where does it go? In the 1990s, physicist Leonard Susskind proposed a mind-bending solution. The information isn't lost. Instead, it's smeared across the black hole's event horizon, the point of no return, like data etched onto a cosmic hard drive. Here's where it gets stranger. If a black hole's three-dimensional interior can be perfectly described by information painted on its two-dimensional surface, could the same be true for the entire universe? Imagine the cosmic equivalent of a basketball. The leathery surface of the 2D boundary holds all the information needed to reconstruct every dribble, every pass, every point scored in the 3D game inside. The holographic principle suggests our reality works the same way. Every star, every planet, every thought in your head could be the projected shadow of information stored on some unimaginably distant surface at the edge of the cosmos. Don't reach out to touch your screen just yet. This isn't about literal holograms like your credit card's shiny security sticker. It's about the fundamental nature of space and time. Think of it like zooming in on a digital photo. At first glance it looks sharp, but if you keep enlarging it, you'll eventually see the pixel grid beneath. The holographic principle hints that reality might have a similar resolution limit, where if you could peer deep enough into the fabric of space, you'd find everything is built from infinitesimal bits of information, like the universe's ultimate pixels. The craziest part, there's actual evidence. Physicists studying the cosmic microwave background, the afterglow of the Big Bang, found strange anomalies in its noise that match predictions made by holographic models. Other experiments with quantum gravity even suggest that spacetime itself might emerge from something more fundamental, like 3D reality, condensing out of a deeper 2D code. So if the universe is a hologram, who or what is holding the projector? That's the million-dollar question. Some theorists argue it's a natural consequence of how information and gravity interact. No outside projector needed. Others whisper about even wilder possibilities, like our universe being simulated on some unfathomable cosmic computer. Whatever the answer, one thing's clear: reality is far weirder than we ever imagined. The next time you gaze up at the night sky, remember you might not just be looking at stars, you could be staring at the universe's grandest illusion. For decades, dark matter has been the universe's invisible scaffolding, the glue holding galaxies together, the unseen hand shaping cosmic structure. Every spiral, every elliptical, every dwarf galaxy we've studied appears wrapped in this mysterious substance, its gravitational pull keeping stars from flying apart. But astronomy loves an exception, and NGC 1052-DF2 is the ultimate cosmic rebel, a galaxy that somehow exists without any dark matter at all. Discovered in 2018, this ghostly galaxy defies everything we thought we knew. Unlike the Milky Way, where dark matter outweighs visible stars 10 to 1, DF2's motions can be explained by ordinary matter alone. Its stars drift lazily, barely spinning, as if the universe forgot to give this galaxy its dark matter starter pack. At first, astronomers thought they'd made a mistake. Maybe the measurements were off, or perhaps the galaxy was just an illusion. But follow-up observations only deepen the mystery. DF2 isn't just lacking dark matter, it's practically allergic to it. So how does a galaxy form without the ingredient we thought was essential? One theory suggests DF2 might be the aftermath of a cosmic train wreck. Picture two galaxies colliding billions of years ago. Their dark matter gets stripped away by gravitational forces, while the visible stars merge into this eerie, transparent remnant. Another idea posits that dark matter and regular matter were somehow separated during the galaxy's birth, like oil and water refusing to mix in the primordial cosmic soup. There's even a wilder possibility. that DF2 isn't a galaxy at all, but a vast tidal stream stellar debris ripped from another galaxy and left to wander the void alone. The implications are staggering. If galaxies can form without dark matter, our entire understanding of cosmic evolution needs rewiring. Maybe dark matter isn't the universal architect we assume. Maybe it's more like a cosmic seasoning essential for most galaxies, but not absolutely required. DF2 forces us to confront an uncomfortable truth: the universe might have more than one recipe for building galaxies. What makes DF2 even more fascinating is its ghostly appearance. Unlike most galaxies, which are dense with stars, this one is ultra-diffuse. Its stars are so sparse you could fly a spaceship through it for light years and barely see a single sun. It's like a cosmic jellyfish, its delicate structure barely held together by gravity, and yet against all odds it persists, a silent challenge to our textbooks. Now here's the real kicker: DF2 isn't alone. Astronomers have since found a handful of other dark matter-deficient galaxies, each one raising more questions than answers. Are these cosmic oddballs mistakes of nature, or signs of a deeper, undiscovered principle? Every time we think we've pinned down the rules of the universe, it throws us a curveball like DF2, reminding us that the cosmos still has surprises up its sleeve. So the next time someone tells you dark matter is everywhere, remember, somewhere out there, a galaxy didn't get the memo. Rising from the heart of our galaxy like a pair of colossal hourglasses, the Fermi bubbles are one of the Milky Way's most mysterious structures, towering geysers of superheated gas and gamma rays stretching 25,000 light-years above and below the galactic plane. That's enough to cover half the distance from Earth to the center of the Milky Way, an eruption so vast it could swallow entire star systems in its path. And the strangest part, we didn't even know these bubbles existed until 2010, when NASA Fermi Gamma Ray Space Telescope accidentally spotted them while mapping high-energy radiation across the cosmos. Picture this: two symmetrical orbs of scorching plasma, each glowing with the energy of a million suns, erupting from the galactic core like a cosmic sneeze. The edges of these bubbles crackle with gamma rays light so energetic it could pierce through lead, while their interiors churn with particles moving at nearly the speed of light. What could possibly create such a titanic structure? The leading suspect is Sagittarius, a star, the supermassive black hole at our galaxy's center. Scientists theorize that millions of years ago, this gravitational behemoth went through a violent feeding frenzy, devouring enormous amounts of gas and dust in a cataclysmic spree. The resulting energy, equivalent to hundreds of supernovae exploding simultaneously, might have blasted outward in opposing jets, carving these gargantuan cavities into interstellar space. But there's another, even wilder possibility. These bubbles could be the aftermath of a star-forming frenzy. Imagine hundreds of massive stars igniting in rapid succession near the galactic center, their combined stellar winds and supernova shockwaves punching through the Milky Way's gas like a cosmic blowtorch. Supporting this idea are the bubble's crisp edges. Unlike the ragged boundaries you'd expect from a chaotic black hole outburst, they're remarkably smooth, as if sculpted by sustained pressure over millennia. Here's what makes these gamma-ray titans even more fascinating. They're not just a relic of the past. Observations show the bubbles are still crackling with activity, their particle emissions interacting with the galaxy's magnetic fields to create eerie, harp-like filaments of X-ray light. Some researchers speculate they might even be recharging periodically, with new surges of energy from the galactic core inflating them further like a cosmic set of lungs. The Fermi bubbles are more than just a spectacular light show. They're a clue to our galaxy's volatile history. Their existence suggests the Milky Way isn't the serene spiral it appears to be, but a dynamic system capable of unleashing unimaginable violence. And if something this colossal could hide in plain sight for so long, what other secrets might our galaxy, or any galaxy, still be keeping? Every time you gaze up at the night sky, you're not just looking at stars, you're peering into a cosmic scrapbook, flipping through pages of history written in light. Those pinpricks of brightness aren't showing you the present, they're delayed broadcasts from the past, some so old they left their source before humans built the first cities. Take Sirius, the brightest star in our sky. Its light takes 8.5 years to reach us, meaning you're seeing it as it was when smartphones were still a novelty. But that's just the neighborhood. The Orion Nebula's shimmering glow, that's a 1,000-year-old postcard, and the Andromeda Galaxy, its light has traveled for 2.5 million years, so when you spot it, you're witnessing a time when early humans were just figuring out how to tame fire. This astronomical time warp works both ways. Just as we see stars as they once were, any alien civilization with powerful enough telescopes would be seeing Earth's past. A hypothetical observer in the Alpha Centauri system, 4 light-years away, would currently be watching the events of 2020 unfold. Your social media posts from that year might literally be passing by their planet right now. Meanwhile, beings in the TRAPPIST-1 system, 39 light-years distant, would be witnessing the moon landing as if it were live television. The farther out you go, the deeper into Earth's history they'd peer. Somewhere near the edge of our galaxy, 80,000 light-years away, a distant astronomer might be studying the migration patterns of woolly mammoths. But here's the mind-bending part: this isn't just about distance. The universe expands at such scales that some light will never reach us. Galaxies at the observable universe's edge are receding so fast their light is stretched into oblivion, their stories forever lost to cosmic static. And just as haunting, the light from Earth that's already traveled beyond 65 light-years carries broadcasts of Hitler's Olympics, our first powerful radio signals. That means for any civilization beyond that radius, we're still a silent, prehistoric planet. What makes this cosmic timekeeping so profound is how it reshapes our sense of connection. That star you wish on tonight might have died centuries ago, its light still traveling like a final love letter, and when you spot the faint smudge of the Triangulum Galaxy, you're glimpsing 3 million years into its past, around the time our ancestors first walked upright. The night sky isn't just a map of space, it's a mosaic of eras, a reminder that every glance upward is a conversation across the ages, so the next time you look at the stars, remember you're not just an observer. You're an archaeologist of light, holding shards of history that have been racing through the void just to meet your eyes. Every atom in your body, the iron in your blood, the calcium in your bones, even the carbon that forms the foundation of your DNA, was forged in the heart of a dying star billions of years ago. That's not poetic exaggeration, it's scientific fact. When Carl Sagan famously said we're made of star stuff, he meant it literally, the oxygen you're breathing right now. Created in a supernova explosion before our solar system existed, the gold in your jewelry, forged in the collision of neutron stars, a cataclysm so violent it ripples the fabric of spacetime itself. You aren't just observing the universe, you're carrying fragments of its most dramatic moments inside you. Let's break down this cosmic ancestry. In the beginning, the universe contained only hydrogen, helium, and trace amounts of lithium, the simplest ingredients. But life as we know it requires heavier elements: carbon for organic molecules, oxygen for water, iron for blood. These couldn't form until stars took that primordial hydrogen and compressed it under unimaginable pressure, fusing atoms together in their cores like celestial alchemists. Smaller stars like our Sun can only cook elements up to carbon and oxygen, but the real heavyweights, elements like gold, platinum, and uranium, require something more extreme: the explosive death of massive stars in supernova, or the universe's ultimate pressure cookers, neutron star mergers. Here's where it gets personal. About 4.5 billion years ago, a nearby supernova likely triggered the collapse of the gas cloud that became our solar system. That means the atoms now in your body were part of an interstellar recycling program, ejected from a dying star, drifting through space for eons, before finding their way into Earth's primordial soup. Every time you inhale, you're drawing in nitrogen atoms that once floated in the voids between galaxies. When you cut your finger, the iron in your blood carries the echo of a star that died before Earth existed. This cosmic connection isn't just poetic, it reshapes how we see ourselves. The same forces that govern distant galaxies also arrange the atoms in your brain, allowing you to ponder their origins. The universe didn't just create us, it became us, and when we eventually return our atoms to the cosmos through decomposition, cremation, or even future space travel, we'll rejoin that grand cycle, perhaps one day becoming part of new stars, planets, or even other conscious beings. So the next time you feel insignificant under the night sky, remember, you're not separate from the universe looking in. You are the universe, momentarily assembled into a form that can marvel at its own existence. Those stars overhead aren't just distant lights, they're long-lost relatives, and the proof is written in every cell of your body. As Sagan put it, we are a way for the cosmos to know itself. And that might be the most astonishing truth of all. We've journeyed through 30 mind-bending cosmic truths, from black holes that warp time to planets where it rains molten glass, from invisible dark matter shaping galaxies to stars cooler than your morning coffee. Each revelation peels back another layer of the universe's infinite strangeness, proving reality is far more extraordinary than fiction could ever invent. These aren't just abstract facts, they're humbling reminders that the cosmos operates on scales and rules we're only beginning to comprehend. Consider our tiny place in this grand tapestry. Every human who's ever lived exists on a pale blue dot smaller than a pixel in the vast Hubble ultra-deep field image. Yet here we are, bundles of stardust somehow capable of unraveling quantum mysteries, measuring the spin of distant pulsars, and decoding the chemical signatures of galaxies billions of light years away. There's profound beauty in this paradox. Though we're cosmically insignificant in size, our curiosity gives us a front-row seat to the universe's greatest wonders. Which fact reshaped your perspective the most? Was it learning that most of the universe is invisible to us, or that sunlight touching your skin began its journey when woolly mammoths still roamed? Perhaps it's realizing the atoms in your hands once witnessed the birth and death of stars, or that somewhere out there, diamond planets and metallic snow defy everything we thought possible about worlds. Every one of these truths invites us to marvel at the cosmic story. We're all part of a narrative written in supernova and quantum fluctuations, where even the laws of physics occasionally bend to reveal new mysteries. So keep looking up with wonder. Share which cosmic truth stunned you most in the comments, because the universe isn't just something we observe, it's a conversation spanning 13.8 billion years, and your voice belongs in it. Who knows, the next revolutionary discovery might begin with someone, somewhere, gazing at the stars and daring to ask, what if?